So welcome to another segment of my mathematics video. So today I'm going to give you concept under vectors in your paper 2. So I'm going to give you some few concepts that you need in your ECZ paper 2 exams. Now if you still remember, we did mention that a vector is simply a quantity that has both magnitude and direction. So a vector is simply we can simply say is a quantity. Let me just try to use a different marker. So we are simply saying it's a quantity that has both magnitude. So it has got both magnitude and direction. So two things actually stand out when you're dealing with vectors: the magnitude as well as the direction. So a vector is always going to tell you the magnitude. When I talk about magnitude, I simply mean the size of something, how big something is, and of course the direction in which it is moving. And therefore you need to pay attention when it comes to the size and also the direction. And therefore as such, you are going to find that, for example, if you have the vector maybe AB moving from A to B. So we are going to put up an arrow to show the direction in which it is moving. So the arrow says you are starting from A and going to B. So it's like your starting point is A and your end point is simply B. And that is why the vector is simply saying AB. So this is like your starting point and this is like your ending point that you have. Therefore on top, we put up an arrow. Now the vector AB can be represented by smaller magnitude vectors. For example, if we can tell you the exact magnitude of this directed line segment AB, maybe we can say it is 4 vector A. So if we are using small letters, normally we put up a dash at the bottom. So you're going to be seeing more of that. We are going to be, for example, again, if I'm representing maybe the vector, let me say OA is equal to maybe 3 vector B. Let me say 3 vector A, you see a dash. If I'm saying OB is equal to maybe 2 vector A, 2 vector B there, you are going to see me, put up a dash when it comes to the lowercase letters that we are going to be representing. So those are representing magnitudes of a vector. Now, concept that you need to remember under vectors, you are going to be dealing more with what we are calling as being, ratios. So you need to understand your ratios because most of the questions that are going to be coming in the exam, they are going to be asking you to be dealing with ratios. Let's say that I've got a line that I'm calling as being, A, B. Then along that one, I do have, X. Let me put my X somewhere here. So let me say I do have my X there. Now the total length or the magnitude rather of the line AB, let's say that the magnitude of this line is simply 5 vector A. And I tell you that the ratio of AX to XB is in the ratio 1 to 3. That's what I tell you. So let's say that the ratio in this case is 1 to 3. What does that mean? Well, it is possible you can know what AX is. So according to what that simply means, we can also rewrite this one if we want. In some exams, you're going to find that this can also be written as AX over XB. It is in the ratio 1 over 3. So that's the way they can actually write that. So it is just the same. You don't need, to get worried with that. So what that simply means is that, AX is represented by a ratio of 1. So it's like the ratio of AX is simply 1. And the ratio of XB, meaning starting from X to B, is simply a 3 there. That's what they mean. No wonder we are simply saying that the ratio AX to XB is in the ratio 1 to 3. So that is what we mean when it comes to that. Now, suppose you wanted to know, the magnitude from A to X. What can you do? Well, if they told you to find the magnitude from A to X, and remember, the magnitude of the whole vector AB, what you can do is that you ask yourself, what is the ratio of A to X? So the ratio A to X is simply 1 over what is the total ratio of the line AB? So you add the ratio 1 plus 3, that will give you 4. So it is simply 1 over 4 multiplied by the magnitude of the whole vector, which is the vector AB. So that is equal to 1 over 4 multiplied by 5 multiplied by vector A. Of course, if you multiply that, I can say over 1 5 times that will give me 5 vector A, then 4 times 1 will give me 4. So meaning AX is simply represented by 5 over 4 vector A. That's what we mean there. Suppose again I told you to find what is the exact ratio of X to B. Well, you do the same, we use the same concept, meaning that if I wanted to know just from X to B there, what I was going to do again, you need to ask yourself, what is the ratio of X to B? It is simply represented by 3 over the total ratio. So by adding 1 plus 3, which will give you a 4, then again you multiply by the magnitude of the vector AB. So that would have been 3 over 4 multiplied by AB represented by 5 vector A. So when you multiply that, that is going to give me 15 vector A over 4. I'm just leaving it like that. So that's my ratio XB there that we mean. So ratios are very important, and please pay attention when it comes to these ratios. Now, I want to give you another concept on ratios that you're going to be finding in your exam, Suppose again, you are given, in this case, you are given the line again. I'll simply say AB, and this time you are again given, X. But I tell you to say that the ratio AX to AB is in the ratio maybe 2 to 3. And I still tell you that the magnitude of this entire vector is simply 5 vector A. How can you deal with that ratio? Remember what I told you, these ratios can be written as AX over AB, which is equal to 2 to 3. Please pay attention to the vectors when they give you in the exam. So this one says A to X is a 2. So meaning the distance from A to X is simply representing a 2. So there we can represent a 2. But again from A, so from A to X, it is representing a ratio of 2. But from A to B, it is representing a ratio of 3. So meaning, since again I'm starting from A to B, not from X to B, remember I'm starting from A to B, it is simply 3, meaning they have actually included these 2. So if the ratio is simply, a 2 there, it simply means here it is going to be a 1. That's what it simply means, such that when you add this plus that gives you a 3. No wonder they tell you the ratio AX to, again they start from AB, is simply 2 to 3. So please pay attention there. So meaning AX is a 2. If I start again from A to B, if it is a 3, it simply, since I already have a 2 there, then 3 minus 2 gives you a 1. So the ratio of AX is simply 1. So you need to pay attention to that. So meaning that if I wanted to know what AX is, I would have found what my AX is by simply saying 2, the ratio, over the total ratio 2 plus 1, which is a 3, multiplied by the whole vector, which is AB. So it would have been 2 over 3 multiplied by 5 vector A. So of course that would have given you 10 vector A over 3. That's what we mean there. In the similar way, if they did ask you to find XB, you are going to say, what is the ratio of XB? It is 1 over the total ratio, which is a 3, multiplied by 5 vector A. So it would have been 5 vector A over 3. So this is what you could have actually done. So that is what we mean when it comes to the ratios. Very important. All right, let's try to give you other concepts that you're going to be finding under vectors. Now, if you have a line and they are telling you are moving from A to B, and there's an arrow telling you are moving from A to B, and let's say from A to B is represented by a vector AB. Of course, when it comes to vectors, the direction of the vector is very important. If the vector is telling you are moving from A to B, please, you need to maintain the direction of the vector. So the vector from A to B, it is represented by a magnitude of vector A. That's what they mean there. Now, suppose I wanted to move in the opposite direction to the actual vector. I wanted to move B to A. How would that be if I wanted to move from B to A? Now, you notice that the actual vector tells you need to be going, according to the arrow, it tells you need to move from A to B, but you want to move from B to A. So what we do to find this vector, we say it's negative, but you maintain the direction of the actual vector, which is AB. The actual vector tells you should move from A to B, but you put in front a negative. What does this negative there mean? Well, the negative is simply means you are moving in the opposite direction. In the opposite direction to what? To the vector BA. That's why we put up a negative there, but we maintain the actual direction of the vector. So that negative tells you you are moving in the opposite direction to AB. So what's the opposite direction of AB? It is BA, and that is why you can have that. Therefore, your BA would have actually been negative. AB can be represented by the magnitude they have given us, which is simply vector A there. That's what we mean. So it's the opposite of that. So please, this concept is very important and you need it to answer, questions in the exam. Another concept that you need to remember is what we are calling as being position vectors. So let me just try to look at what we are calling as being, position vectors. Now, what exactly are position vectors? Well, position vectors, I can simply say that these are vectors, so these are vectors starting from the origin. So vectors that start from the origin, if you have your x or y plane, they are starting from the origin 0, 0, then it simply means we call them as being position vectors. So let's say we have got a point A, and from O to A, when you draw a line, let's say it is represented by vector A. From O to B, let's say that it is represented by vector B. Then they tell you to say they want you to move from A to B. How can you find from A to B? So remember, from A to B, it simply means for me to move from A to B, and remember, you can only move where you have a rod, you have a vector, so to say. That's why you can move. So the only way I can move is AO, if you notice, so that is going to be AO, combined with the vector OB. So that is what we mean. So that's how I can move from A to B. It is AO combined with OB. But you notice if you move from A to O, you are moving in the opposite direction to the vector. So what do? You put up a negative, but you maintain the actual direction of the vector, which is OA. That's what we mean, combined with the vector OB. So in most cases, if one vector that you're having is positive and the other one is negative, the negative should be taken inside. So you can start with OB, which because it's positive, combined with the vector OA. Combined, I just mean you're adding there still, it will be a negative there. So that's what we mean. So if it is in terms of the magnitude of what they have given me, OB is represented by vector B, minus OA is represented by vector A. So that is what you need to remember. Now let me show you a quick way of trying to go about that. You don't need to waste time. So if they want you to find, in this case, the vector AB, you would have just gone direct. So let me just give you an alternative. Remember what they tell you from A to B. So what you simply start with this one here, the last vector. So because it's starting from the origin, meaning you start with this one, it will be OB minus this one will be a negative. You'll be moving in the opposite direction. So it's OB, minus, in this case, OA, combined with OA. That's what we mean. So you don't even need to waste time. So this is the stage that I have here. That's the stage. So start with this one and end with this one. This one will be positive and this one will be a negative. So if you're starting from the origin, start with this one. It's OB minus OA. That's what we mean. So therefore, it would have been OB is vector B minus OA vector A. You can see that it is actually much quicker and shorter. Now let's do the opposite there so that we can give you some more concept that you need on that. Suppose now I told you that you find the vector, sorry for my poor straight line. Suppose I told you to move from B to A. Suppose I told you to move from B to A. If you remember the concept, you can start with this one. That's the first one. It will always be positive. So because it's starting from the origin, it will be OA in this case. So it will be OA, combined minus the vector OB. Remember the first one? This one will be positive and this one will be negative. So start with this one, OA minus OB. So what is our OA? It is vector A minus OB, which is vector B. I hope you have gotten the concept, and these concepts are what you're going to be using. So get to know, how to find the ratios, to deal with position vectors, because that is what you are going to be finding in the exam. So I was using this diagram to just help you with position vectors. Now let's look at an examination question and show you how you can go about answering that. So with me, I do have, this 2024 paper 2 question number 3B GCE question. So let's try to see how you can go about answering such a question. It says in the following diagram, OA is represented by vector A, so OA vector A, then OB by vector B, and the ratio AX to AB is in the ratio 2 to 3. So AX to AB is in the ratio 2 to 3. So please pay attention with that ratio. We are going to use it. Then 1 says express in terms of vector A and or vector B. So they want us to find from A to B. So from A to B, how is that going to be? So that is Roman 1, from A to B. Remember, this is a position vector. It is starting from the origin. That's why they have given you O there. So how do I move from A to B? It is AO and O combined with OB. But remember, AO is in the opposite. So use what I taught you. You start with this one because it is going to be always positive. So it is OB minus the vector OA. That's what we mean. So that is going to give us the vector OB, vector B minus the vector OA. It is simply vector A. So this is what they wanted us to do there. And it's very simple. You can notice when you move from A to B, you are going to move in that direction. But when you move in this direction, you are moving in the opposite direction. So therefore, start with the positive OB, then minus OA. So that's what we mean. Remember that negative means you are moving in the opposite direction to OA. And what's the opposite direction to OA? It is AO. That's what we mean. Let's move on to Roman 2 there. It says XB. So what is X to B there? So you want to move from X to B. Now, how do I find, the magnitude of X to B? Now, the way vectors are, since you have found AB, meaning you can use this route because you have now found the vectors representing the directed line segment AB. So you can use it. And that's what you're going to be doing. Your previous answer will be used in subsequent, questions that you answer. So pay attention as you answer previous one and refer to them and see if they can work out for you. So for me to find XB, they gave us that ratio. So we'll go back to that ratio. They gave us to say AX to AB is in the ratio 2 to 3. So AX is representing a ratio of 2. But again, they say starting from A to B, it is representing a ratio of 3, meaning you have already covered these two. So what's the ratio of X to B? It is simply 1. That's what it simply means. So 3 from A to B minus these 2, that will tell you XB, which is a 1. So therefore, how do I find XB? You look at the ratio of X to B. It is simply 1 over the total ratio of that line, 2 plus 1, which is a 3. Then multiply by this whole line, the vector for this whole line, the directed line segment AB. So multiply by the vector AB. So this is going to be 1 over 3 multiplied by AB, which is vector B minus vector A. That's what we mean. So if you want, you can go further and multiply 1 over 3 times that one. It will give you 1 over 3 vector B. 1 over 3 times vector A will give you 1 over 3 vector A. If you wanted, you would have ended there or you would have gone there. But others would have preferred also writing this as simply vector B minus vector A over 3. That's what they would have done, because this is over 1. 1 times that will give you that. 3 times 1. So any of these, you would have ended there. That's okay. All right. So we should be remembering this. So I'll just be writing the solutions there. Vector B minus vector A. This one there, I can simply use vector B minus vector A, over 3. Let's move on to the C part there. Let's move on to the C part. So according to the C part there, it says you find number 1C. It says we find XO. So we find XO. So my previous one it's supposed to be A, B, and C under Roman 1 there. So what is my X to O? So remember, it says your starting point is X, then your ending point is O. So since I've found what XB is, you can use it. So how do I move from X to O? I can move XB combined with BO. So it is going to be XB combined with BO. So it is going to be XB combined with the BO. But remember, XB is in the actual direction, but BO is in the opposite direction. So it will change it to be negative, but maintain the actual direction of this vector, which is OB. And what does that negative tell you? That negative tell you are moving in the opposite to OB. What's the opposite of OB? It is BO, and that's what we have there. So what is my XB? That's what we found there, vector B minus vector A over 3 minus, what is vector B? It is simply vector B. So you can do your algebra. I can say this can be written over 1 and find the common denominator so that we work out the simple algebra. So what's the common denominator? It's a 3. 3 into 3 is 1. 1 times B will give you vector B. 3 into 3 is 1. 1 times that will give me vector A. 1 into 3 is a 3. 3 times that one will give me minus 3 vector B. So you can work out that. So my XO will be equal to, if you notice, negative of vector A. B minus 3B. B minus 3B will give you negative 2 vector B. So that would be negative 2 vector B over 3. So you can end there. So that is what we mean. All right. So that is your XO there. So that is your XO. That is what you needed to do. All right. So what are we going to do next when it comes to that one? Well, now for us to do the Roman 2 there, let's try to look at that one. So we have now established what our XO there is. It is negative of vector A minus 2 vector B over 3. So we need to remember that. All right, let's look at Roman 2. So how do I do Roman 2 there? So Roman 2 says, given also that OY, for you to move from O to Y, you can also say it is 3 multiplied by the vector OX. In other words, it is 3 times the vector OX. That's what we mean. But do you know OX? Do you know what OX is? Well, remember, you can find what your OX is there. How do you get your OX? For me to get OX, remember, don't say we have found it. This is XO and this is OX. So for you to get OX, it is simply OX. If you want, you can say it's negative over the vector XO. XO. That's what we just need to say. Why? Because XO, OX, you are moving in the opposite direction of XO, which is OX, and that's why I'm adding just that negative. So it will be negative multiplied by negative A 2B over 3. So negative and negative give me positive. Negative and negative, it will be positive there. So you're going to have a positive. So that's XO. So what are we going to do there? It will be 3 multiplied by OX. So you get that one there, which is vector A plus 2 vector B over 3. If you notice, this and that will cancel, I'll remain with vector A plus 2 vector B. So that is OY. And each time you need to find this one, because what they mean, you are going to use this to show that BY is equal to that. So how do I show that BY is equal to, how do I show that BY is equal to that? So for you to move from B to Y, you need to involve OY. That's why they have given you this expression. So which direction should you move but involving OY for you to move from B to Y? So for me to involve OY, it simply means I'll move B O combined with OY. But remember, you can use that concept I told you. Start with this one, it's always positive. So it will be OY combined, in this case, minus OB, because I told you this will be negative if you are starting from the origin. So OY is represented by vector A plus 2 vector B minus, what is OB? It is simply vector B. So you can see it will give you vector A, 2B minus B, it will give you positive B. You can simply say hence shown. So you have actually shown for them. So this is what we have actually shown. So that's basically how you can go about it. I'll look at some more practice questions so that I can just help you, but please go through these basic concepts. Thank you so much for watching my video. Watch out for more concepts under vectors.